Hello, in this video I'm going to be going over molecular geometry and also hybridization, and we'll talk a little bit about bond angles, but bond angles will most likely be bonus on any assessment. So, looking at molecular geometry first, it's going to be linear if you have 1, 2 outer atoms and 0 lone pairs. And a lone pair, remember, just a quick example, we have water has 6 outer electrons because it's in column 6A, and it has 2 hydrogens and 1 bond. Alright, a lone pair is a pair of electrons that are not involved in bonding. So H2O has 2 lone pairs and 2 bonded pairs. So when we're looking at linear, it has 2 bonded pairs and 0 lone pairs. Usually it's going to have a double or triple bond. Trigonal planar has 1, 2, 3 outer atoms and again 0 lone pairs on the center atom. When we're looking at lone pairs, we're just focusing on the center atom. The outer ones do not matter, it's the center atom. Bent is going to have 1, 2 outer atoms and 1 lone pair. And the reason that is because this lone pair repels the other electrons in here, bending that molecule, whereas linear had 0 lone pairs, so it's not being bent by repulsion of those lone pairs, those electrons. Then we have tetrahedral has 1, 2, 3, 4. Tetra stands for 4 terminal or outer atoms and 0 lone pairs on the center. And as you look at the bond angles, we have 180 flat line for linear, 120 for trigonal planar, less than 20 for bent with a single lone pair, 109.5 for tetrahedral. Some of these, like linear, might be easier to memorize, or 109.5, maybe 120 for trigonal planar. I think it's a little trickier. It's around 107, less than 109.5 for trigonal pyramidal. A little more involved. Trigonal pyramidal has 1, 2, 3 outer atoms, and it has 1 lone pair on the center, so it's kind of like tetrahedral. Only instead of a bonded pair, it has a lone pair. Then we have another bent, which is the bent that water is. 2 outer atoms and 2 lone pairs on the center atom, around 105, or less than 109.5 angle. Then we get into the expanded octet. So really, these first few, those first 6 are just the basic common ones, and then once you expand the octet, you get to all these nitty-gritty details. So here we have 1, 2, 3, 4, 5 outer atoms. That's trigonal bipyramidal. Seesaw has 1, 2, 3, 4 outer or terminal atoms and 1 lone pair on the center. Then we have T structure, looks like a T, has 1, 2, 3 outer atoms and 2 lone pairs, whereas linear, again, is 180 bond angle, 2 outer atoms, but this linear has 3 lone pairs, whereas the top linear had 0 lone pairs. Alright, and then we have octahedral that has 1, 2, 3, 4, 5, 6 outer atoms, 0 lone pairs, square pyramidal 1, 2, 3, 4, 5 outer atoms, 1 lone pair, and square planar 1, 2, 3, 4 outer atoms, 2 lone pairs. So, you're going to have to know these shapes. A lot of this is just memorization. That's the tricky part. If you memorize it, you'll be fine. If you don't memorize it, it's going to be a little tricky. So, doing some examples, we have some Lewis structures drawn already. And we looked at O2. Anytime you have just 2 atoms, it's going to be linear. It's like 2 dots. The only shape you can make with 2 dots is a line. So this one is definitely going to be linear. Alright, but now we have 3 atoms. If you have 3 atoms, it could be linear, but it could also be bent depending upon lone pairs. So here we have 2 outer atoms. So if we look at our sheet, we have 1, 2 outer atoms. That could be linear, or 1, 2, 1, 2. It could be bent. It's either linear or bent. The difference is 0 lone pairs on the center atom, 1 or 2 lone pairs on the center atom for bent. So one has lone pairs, one doesn't. Linear, no pairs. Bent, lone pairs. This guy, carbon, has 0 lone pairs. Therefore, it would have to be linear. Looking at H2S, this one has 2 outer atoms, so it could be either linear or bent. And this one has 2 lone pairs, so it is bent. Moving on to the next one, we have, okay, so now we have 1, 2, 3 outer atoms. So we have 3 outer atoms. That could either be 1, 2, 3 trigonal pyramidal or 1, 2, 3 trigonal planar. Either or. Again, the difference, if it's planar, it has 0 lone pairs. If it's pyramidal, it has 1 lone pair on the center atom. So this guy has 1, 2, 3 outer atoms, and on the center atom it has 0 lone pairs. So that would make it trigonal planar. Trigonal planar. Alright, looking at methane, CH4. This one has 1, 2, 3, 4. There's really only one type of molecular structure or shape that has 4 outer atoms, 1, 2, 3, 4, 0 lone pairs. That's tetrahedral. Alright, so CH4 is tetrahedral. Looking at NH3, it has 1, 2, 3. It's just like COH2 has 1, 2, 3. Difference is this guy has a lone pair. So if it has 0 lone pairs on the center, it's trigonal planar. If it has 1 lone pair, it's trigonal pyramidal. This one is trigonal pyramidal. Alright, looking at CO3, this one has 1, 2, 3 outer atoms, 0 lone pairs. Just like this one had 1, 2, 3 outer atoms, 0 lone pairs. It's going to be trigonal planar. This one, CF4, 4 outer atoms. It's like CH4, 4 outer atoms, 0 lone pairs on the center. That's tetrahedral. Alright, continuing with some more examples. Alright, for SO3 we have 1, 2 outer atoms and 1 lone pair. So 2 outer atoms and a lone pair. Looking at this guy, it says 2 outer atoms with 2 lone pairs. 3 outer atoms, here we go. 2 outer atoms, 1 lone pair. That's bent, less than 120 bent. So this guy is bent. The other one, phosphate with 3 minus, has 1, 2, 3, 4. No lone pairs on the center. That would be tetrahedral, where it has 1, 2, 3, 4, none on the center. Right, tetrahedral. Alright, and now getting to the octet rule. So all of these guys. First of all, we have the ones that have less than 8, 1, 2, 3, 1, 2, 3. It's like trigonal. So it's either trigonal planar or trigonal pyramidal. Pyramidal, it would have a lone pair on the center atom. Planar, it would have 0 lone pairs on the center. Both of these have 0 lone pairs on the center atom, so they are trigonal planar. Trigonal planar. Looking at XeF4, we have 4 outer atoms and 2 lone pairs. 1, 2, 3, 4 outer atoms, 1 lone pair. 3 outer atoms, 2, 5, here we go, 1, 2, 3, 4 outer atoms and 2 lone pairs. This one's square planar. So we'll write that down. Square planar. And then here we have 1, 2, 3, 4, 5, 6 outer atoms, no lone pairs on the center. That one's a nicer one. 1, 2, 3, 4, 5, 6. That one's going to be octahedral. So we got octahedral. And then here we have 1, 2 outer atoms and 3 lone pairs. I'm guessing linear. 2 outer atoms, 3 lone pairs, and that's linear. And it's basically made a line because of the repulsion of these lone pairs. Alright, PO4, 1, 2, 3, 4. I think we already did that one. but it's tetrahedral. 1, 2, 3, 4, 5. So we have 5 outer atoms, 0 lone pairs. That would be this guy, 1, 2, 3, 4, 5. Trigonal Pyramidal. No lone pairs. Trigonal. Y or I? It's with a I. By pyramidal. This guy's 1, 2, 3, 4, 5, 6. That's going to be just like this guy, octahedral. Alright, the last two examples are going to be this guy and this guy. This guy has 1, 2, 3, 4 outer atoms and 1 lone pair. So 4 outer atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4 outer atoms, 1 lone pair. This guy is seesaw. Call this one seesaw. And this one has 1, 2, 3, 4, 5 outer atoms and 1 lone pair. 5 outer atoms, 1, 2, 3, 4, 5 outer atoms, 1 lone pair. That's square pyramidal. Yeah, alright. Alright, and that is molecular geometry.